This is lesson 2-3, standard form of a linear equation. Now don't forget to do the name, date, and period on the top. So the objectives: write and graph linear equations in standard form. And use the linear equation in standard form to interpret both the x and y intercepts in the context of a given data. Our vocabulary for lesson 2-3 is standard form of a linear equation, x-intercept, and y-intercept. The essential understanding is that the standard form of a linear equation is helpful for identifying the x and y intercepts, and they are used to graph the line and to aid in understanding the constraints within a real-world example and context. The standard form of linear equation is ax plus by equals to c, where a and b are integers and a and b are not both equal to 0. So here is our first example. Hannah will spend $150 on music festival tickets. Reserved seat tickets cost $25, and the general admission tickets cost $10. So, the part A, how can you represent the situation with a linear equation? Remember our standard form, which is ax plus by equals to c. Well, we know that Hannah will need to spend $150 total on the music festival tickets. So the $150 is the C. And we also know that Hannah will need to buy both the reserved seat tickets, and the general admission tickets, which would be our A, and the other part would be our B. So we will go ahead and put those into our standard form. 25x is our reserved seat tickets, and B is our general admission tickets, which is $10. Y, and then $150 for the total amount she will need to spend. And there's our standard form. Now, what information does the standard form give you that the slope-intercept form does not? So our standard form is ax plus by equals c, and we know that our equation is 25x plus 10y equals 150. Now we need to put this onto the slope-intercept form. And our slope-intercept form is y equals mx plus b. So we'll need to turn our standard form into the slope-intercept form to compare between the two. Okay. And then we will need to do that by subtracting 25x into the other side. That cancel each other out. And now we have 10y equals 150 minus 25x. We also need to take out the 10 on 10y, so we need to divide. And we'll need to do that on the other side also. So 10 cancel each other out, and we end up with 150 divided by 10 is 15, minus 25 divided by 10 is 2.5x. we can also rearrange this and have this part on the front and say y is equals to minus 2.5x plus 15. And that's our slope-intercept form. So between the two, we know that from our standard form, we can see that Hannah's constraint is $150. And with our slope-intercept form, we can see that Hannah can only buy 15 general admission tickets. So we'll just write that in. Constraint in the standard form is shown. And for the standard form, for our slope-intercept form, our limit for general admission tickets is shown. Now we will need to understand how to graph a line using the x and y intercepts. So x and y. Now when we're looking for the x-intercept, we will need to plug in 0 for x. So over here. So our first problem is 3x minus 2y equals 9. And we will have to plug in 0 for x and then copy the rest. So when we multiply 3 times 0, we come up with 0. So we can just cross that out. And now we have 2y equals to 9. The next step is dividing negative 2 out of 2y. So we will need to divide negative 2 on both sides. Cross these out. And now we have y is equals to negative 4.5. So then we go on our graph on our right side over here and plot in, that's negative 1, negative 2, negative 3, and negative 4. We go right in the middle, and that's where negative 4.5 is. And now for the y-intercept, we will need to plug in 0 for the y on our standard form. So then we have 3x minus 2 and plug in 0 for y equals to 9. So negative 2 times 0 is again 0. So now we have to copy down the rest. 3x equals to 9. That's what we're left behind with. And now we're solving for x. So we need to divide 3 out of 3x and do that on both sides. The 3's cancel each other out. So now we have x is equals to 3. And we'll need to find that on our x-axis. And we'll need to show 3. And now with these 2 points, we can graph the line. And that's how we show that the graph of the line 3x minus 2y equals 9 is through these x-intercepts and y-intercept. Now before we move on to our second problem over here, you might have spotted some mistakes on solving our first problem. So for this part, these two are mislabeled. So the first part was supposed to be solving for the y-intercept. So we will need to move this. And this second part, we solved for the x-intercept. So we're basically switching the two. Oops. And the second part is that on our line, it doesn't just end on our 2 points, on our 2 intercepts. The line actually goes on. So then we can just extend our line and draw arrows on both ends. There you go. And now I will show you guys another easy method to solve for the x and y intercepts of a standard form. So here's our second problem. 4x plus 5y equals to 10. Now when we solve for the x-intercept, we can just cover them where we needed to substitute the 0 in. So that when we cover it, we would just be left behind with 5y equals to 10. And from there, we can simply solve out for the y-intercept. So we need to divide 5 on both sides, and then y would equals to 2. And then when we need to solve out for the x-intercept, we would do it on the other side. We need to cover the 5y, and then now we're left behind with 4x is equals to 10. So divide 4 on both sides, and now we're left behind with 2.5. And we'll just go ahead and graph that. Plot those points, y equals 2 on the y-axis, and then 2.5 on the x-axis, so right in the middle. And then from those 2 points, just draw the line going through. And so here's how we graphed the standard form for 4x plus 5y equals to 10 using our x and y intercepts.